Hi students, Professor Nugent here. In the last two videos, we talked about using the Chow test and the QLR test to test for break dates. In this video, we are going to discuss assessing model stability using pseudo out-of-sample forecasts. Our QLR test, it does not work very well towards the end of the sample. That's why we are trimming 15% beginning and end. But this is usually the most interesting part, the end of the sample, because from there, then we want to make a forecast. One way to check whether the model is working at the end of the sample is to see whether the pseudo out-of-sample, or POOS, forecasts are on track in the most recent observations. This is an informal diagnostic because we will be evaluating whether forecasts are on track by observation, visual observation. This evaluation should complement formal testing using the QLR. The application we are going to use is our GDP term spread model. We have an autoregressive distributed lag model with 2 lags of the GDP growth rate, 2 lags of the term spread on the right-hand side. We are predicting GDP growth rate on the left-hand side. We have previously found a break at 1980 Q4. So when you find a break in your series, one of the things that you can do is to only consider regressions that start after that break. You can look at regressions that start after that break or regressions that end before, one or the other. So we're going to ignore earlier data from the previous model, the previous regime, and focus on data from the regime that follows. So the way that we do pseudo out-of-sample forecasts, we're going to compute the regression over t equals 1980 Q1 through p. And we're going to set p perhaps to, here this is p, we're setting p, for example, equal to 2003 Q1 through 2017 Q4. You know, you might use 80% of your sample for the in-sample model, and that might help you identify what your P is. Computing your pseudo out-of-sample forecast, you will get a forecast of the GDP growth rate at P plus 1, given P, and then, because we're doing a pseudo out-of-sample forecast, you can actually identify forecast error because you know what the GDP growth rate in P plus 1 is. You have a forecast of it and you have an observation of it. So you can identify the forecast error. Let's look at how well the model performs over time. We have plotted the forecast growth rate of GDP that is the dashed black line. The actual growth rate of GDP is the solid blue line, and the shaded blue area is the forecast error. On the left-hand side, we have percentage points, and on the x-axis, we have time. You can see that the forecasts generally track the growth rate of GDP from 2003 to 2017, but the forecast really fails to predict this sharp decline during the financial crisis recession, and you would expect that from such a simple model. Please, to carry out the pseudo out-of-sample forecast, return to this data tutorial that we have done in class and review the code that I have provided on Blackboard. So let's sum up time series forecasting models. For forecasting purposes, the coefficients do not need to be causal, and rarely the coefficients are interpreted for a causal relationship. The tools of regression can be used to construct reliable forecasting models, even though there is no causal interpretation of the coefficients. The autoregressive P lags are common benchmark models. The autoregressive distributed lag PQ, order of PQ, adds Q lags of a variable X, which is another predictor. As in the example of predicting the GDP growth rate, we add lags of the term spread. We can use Granger causality tests, which test whether a variable X and its lags are useful for predicting Y, given lags of Y. And that's in essence an F test, testing that the coefficients on the lags are equal to 0. Finally, we have looked at new ideas and tools in forecasting. We looked at stationarity, which is the idea that the probability distribution of Y is constant over time, so the variances, expected values, the skewness, kurtosis constant over time, so that the model using historical data can be used to predict current and future values. We looked at forecast intervals using the root mean square forecast error, which are different from confidence intervals. We looked at pseudo autosample forecasting. We looked at examples of it, and in our stated tutorial, we actually do pseudo autosample forecasting. We looked at the Bayesian information criterion for model selection. The lag that gives you the lowest Bayesian information criterion is the lag that is chosen by BIC. That is the best model. We looked at ways to check or test for non-stationarity, the Dickey-Fuller test for a unit root. The null hypothesis is that delta is equal to 0, so that the null hypothesis is that you have a unit root against the alternative that the series is stationary. We looked at testing for a break in regression coefficients, a Chow test at a known date. So the Chow test is for if you know tau, and the Chow test is distributed the F distribution. And we looked at the QLR test at an unknown date, which has special critical values that are higher because of the range of possible break dates. You have more opportunities to reject the hypothesis that there is no break, so there's more uncertainty. And finally, we looked at pseudo-autosample analysis for end-of-sample forecast breakdown to see how well the forecast matches the observed